A fraction of a degree sounds like nothing in your daily life. But in the physics of a planet, a 0.85 degrees Celsius increase is a thermal catastrophe. I'm Binglet Wags, and today, we will examine the mechanics of a world out of balance. Between 1880 and 2012, Earth's average temperature rose by approximately 0.85 degrees Celsius. While it sounds subtle, at a planetary scale, this shift represents a massive accumulation of energy in our oceans and atmosphere. Climate systems operate on delicate tipping points. Even a minor thermal deviation can destabilize global ecosystems and rewrite the rules of our economies and societies. Climate change is far more than a weather pattern shift. It is a long-term disruption of Earth's energy budget. While our planet has naturally cycled through ice ages for millennia, those transitions occurred over thousands of years. What concerns the scientific community today is not the fact that the climate is changing, but the unprecedented velocity of the current warming trend. This exponential surge is directly linked to an anthropogenic increase in greenhouse gases. Earth's atmosphere functions as a sophisticated thermal shield. Certain gases, like carbon dioxide and methane, have a unique molecular structure that allows them to trap heat. This is the greenhouse effect. Without this natural insulation, the average global temperature would plummet to -18 degrees Celsius, making life as we know it impossible. However, human activities have disrupted this delicate equilibrium. The burning of fossil fuels is the primary driver, but deforestation, industrial agriculture, and urban expansion are also massive contributors. By releasing gigatons of stored carbon back into the atmosphere, we've effectively thickened the Earth's thermal blanket. Carbon dioxide is responsible for approximately 63% of global warming. From transportation to chemical manufacturing, our modern infrastructure is heavily reliant on processes that shift the planetary balance. The system is warming, and the physics are clear. We are now operating outside the natural climate cycles of the last 800,000 years. Climate change manifests through a dangerous duality: sudden atmospheric shocks and slow systems transformations. Understanding this distinction is key to visualizing our future. Sudden impacts are the violent outbursts of a warming planet. As ocean temperatures rise, storms act like massive thermal batteries, gaining unprecedented energy. Simultaneously, warmer air holds more moisture, leading to catastrophic atmospheric rivers and flooding. From lethal heat waves to the explosive growth of wildfires, our weather patterns are becoming increasingly volatile and unpredictable. Equally significant are the slow, silent transformations. The melting of polar ice sheets and the thermal expansion of water are driving sea levels higher every year. Meanwhile, our oceans are absorbing vast amounts of CO2, triggering ocean acidification, a chemical shift that threatens the very foundation of marine life. We are also witnessing a global hydrological redistribution. In regions like southern Europe, precipitation is plummeting, while northern regions face increasing rainfall. Ecosystems, which evolved over millennia, are now struggling to adapt to shifts occurring in mere decades. We must view Earth not as a collection of parts, but as a single, interconnected system. When ecosystems destabilize, human systems inevitably follow. This is the structural reality of climate change. Biodiversity is more than just nature, it is the infrastructure of life. As ocean temperatures rise, we face the collapse of coral reefs, the nurseries of the sea. On land, desertification is erasing arable soil, while rising thermal stress increases the frequency of devastating wildfires. When species cannot migrate or adapt fast enough, we lose the very foundation of our global food security and medicine. Climate change is also a biological threat. Warmer temperatures are expanding the range of disease vectors. Mosquitoes and rodents are moving into new regions, carrying pathogens like dengue fever and Lyme disease into previously safe areas. Furthermore, intense heat waves are placing unprecedented cardiovascular and respiratory stress on human populations worldwide. The message is clear: the environment is not something separate from us. We are the environment, and its health is directly linked to our own biological survival. Climate change is a massive risk multiplier. It doesn't just change the weather, it destabilizes the very foundations of our global economy. Extreme weather events are no longer just natural disasters, they are economic shocks that destroy infrastructure and trigger acute food insecurity. In low-income nations, these impacts are catastrophic. We are witnessing a sharp decline in agricultural productivity and intensifying water stress. This leads to a tragic reality: mass displacement. When regions become uninhabitable, climate stress amplifies political instability and resource conflicts, proving that our economic systems are inseparable from environmental stability. Indigenous populations are on the absolute front line of this crisis. In the Amazon basin, deforestation and drought are creating a dangerous feedback loop, releasing stored carbon and threatening ancestral lands. In the Arctic, communities that depend on species like seals and reindeer are seeing their food security and cultural identity dissolve as the ice vanishes. From the shrinking lichen pastures of Scandinavia to the expanding dunes of the Kalahari, climate change isn't just an environmental issue, it is a force that intensifies existing marginalization. To protect the planet, we must protect the people who have guarded its biodiversity for millennia. We must acknowledge that climate change does not operate in isolation. It acts as a systemic stressor, interacting with other anthropogenic pressures like plastic pollution and overfishing. In our oceans, these factors create a lethal triple threat, destabilizing marine ecosystems and threatening global food supplies simultaneously. As the cryosphere, our planet's ice, continues to destabilize, sea levels rise, placing nearly 40% of the human population at long-term risk. From the disruption of global hydrological cycles to the disappearance of vital wetlands, the effects are not just additive, they are compounding. The question is, can it be reduced? The scientific consensus is clear: mitigation requires deep, systemic change. It is no longer enough to tweak the current model, we must transition toward a circular economic paradigm, reducing waste, eliminating resource extraction, and restoring natural carbon sinks through massive reforestation. The IPCC emphasizes that transforming our food systems, transportation, and energy infrastructure is central to reaching net zero. While individual actions, like reducing plastic use and optimizing electricity, are essential for collective momentum, the true solution lies in structural transformation. Our habit of consumption must evolve into a strategy of resilience. Climate change is not a distant possibility or a hypothetical future. It is measurable. It is observable. And it is accelerating. The scientific consensus is undeniable: human activity is the primary driver of current warming trends. The challenge we face is no longer just understanding the problem. The challenge is coordinating global adaptation and mitigation at sufficient scale. Climate systems evolve naturally over millennia. But the current rate of warming is unprecedented in modern human history. Even less than 1 degree of change has already reshaped our weather patterns, our ecosystems, and our global economies. The trajectory of the next century depends entirely on the decisions we make today. Climate change is not merely an environmental issue, it is a structural transformation of the planet's operating conditions. Understanding it is the first step. Managing it is the next. Thank you for exploring this topic with me. If you found this analysis valuable, subscribe for more deep dives into the mechanics of our world. I am Binglet Wags. And I will see you in the next one.